Good morning, dear students. How are you? Today we are going to discuss about some simple tricks to find hybridization. This is the trick for the students who find it difficult to decide hybridization, right? So, don't skip the video and watch the video till end. If you are new to my channel, please subscribe my channel and hit the bell icon. Now we are going to discuss this trick. What is the trick? Let us see. If there are two sigma bonds, then hybridization is sp. If there are three sigma bonds, then hybridization is sp2. If there are four sigma bonds, then hybridization is sp3. Two sigma bond means here is number 2. 2 means two orbitals involved in hybridization. 3 means 3 orbitals are involved in hybridization. 1s and 2p. In this case 4. 4 means 4 orbitals are involved in hybridization, 1s and 3p, right? If some atoms have lone pair of electrons, then sigma bonds and lone pair of electrons are counted for determining hybridization, and lone pairs of electrons are also assumed as sigma bond, right? I once again repeat, if some atoms have lone pair of electrons along with sigma bonds, then sigma bonds and lone pair of electrons are counted for deciding hybridization, and lone pair of electrons are also assumed as sigma bond, right? Now we take example and it make you understand very clearly. These are some compounds and we have to decide hybridization at every atom, right? So question is, find hybridization at each atom. Now we find hybridization in these compounds at each atom one by one. First example is we have butane, right? Now we find hybridization at every atom in butane. This is butane, right? We draw structure of butane like this to count sigma bonds, right? Now we take example of this atom. How many sigma bonds are there? 1 2 3 4. 4 sigma bonds are there. And what the trick says, if 4 sigma bonds are there, then hybridization is sp3, right? Now we go to this carbon atom. How many sigma bonds? 1 2, 3 and 4. So sp3 hybridization. Same is the case 1, 2, 3 and 4. 4 sigma bonds. So sp3 hybridization at last carbon atom 1, 2, 3 and 4. 4 sigma bonds. So sp3 hybridization, right? So 4 sigma bonds sp3 hybridization, 4 sigma bonds 3 sp3 hybridization, 4 sigma bonds sp3 hybridization, 4 sigma bonds sp3 hybridization, right? Second example is ethene. Now we have to decide hybridization at every carbon atom. So we start from this carbon atom. How many sigma bonds are there? 1, 2 and 3. 3 sigma bonds are there. So hybridization is sp2, right? Now we go to this carbon atom. Same is the case. 1 sigma bond is there and another sigma bond is there, means 3 sigma bonds are there. So same sp2 hybridization, right? So in ethene both carbon atoms are sp2 hybridized, right? Now we take another example here. We start from this carbon atom. How many sigma bonds are there? 1, 2, 2. 2 sigma bonds are there. So sp hybridization is there. Same is the case. 2 sigma bonds 1 and 2. 2 sigma bonds are there. So sp hybridization is there. In ethine, this is ethine. Both the carbon atoms have sp hybridization. Now we move to next example. Next example is carbon dioxide. This example is a little bit different from the previous one. So in this case there are sigma bonds as well as lone pair of electrons. I once again repeat, in carbon dioxide there are sigma bonds as well as lone pair of electrons. So we can draw the structure of this carbon dioxide like this. We can show lone pair of electrons like this. So there are 6 electrons in valence shell of oxygen, 2, 2, 4 and 2 electrons are in bonding. Same is the case, 2 electrons, 2 more electrons, 4 and 2 electrons in bonding. Now we start from this first oxygen atom. There are 2 oxygen atoms, so we start from this first oxygen atom. 1 sigma bond is there. 1 sigma bonds plus 2 lone pairs of electrons. 2 lone pair of electrons, right? So what is total? Total is 3. I told you already, if 3 sigma bonds are total comes 3, then hybridization is sp2. So this oxygen is sp2 hybridized, right? Same is the case at oxygen number 2, 1 sigma bond plus 2 lone pair of electrons. One lone pair is this and another lone pair is this one. So 2 lone pair of electrons, 2 lone pair of electrons are there. So number comes 3, right? So if number comes 3, or if there are 3 sigma bonds, then what type of hybridization is here? It is sp2 hybridization. So both these oxygen atoms are sp2 hybridized. Now what about this central carbon? One sigma bond is this side, another sigma bond is to this side. So 2 sigma bonds, so this central carbon is sp hybridized, right? Now we move to our next example. This is our ketene. So we start from this oxygen atom. One sigma bond is linked to this oxygen atom. One sigma bond plus 1, 2. 2 lone pair of electrons are there. 2 lone pairs of electrons are there. So total is 3, right? So this oxygen atom is sp2 hybridized, right? Now we take example of this carbon atom, as we already saw such type of carbon atom in carbon dioxide, right? This carbon is similar to carbon atom in carbon dioxide. So 2 sigma bonds are there, 1 sigma bond and 1 sigma bond. 2 sigma bonds are linked to this carbon atom. So if there are 2 sigma bonds, then hybridization is sp. Now we go to this carbon atom. How many sigma bonds are there? 1, 2 and 3. 3 sigma bonds are there. If 3 sigma bonds are there, so what is hybridization? sp2, right? In this case there are 2 sigma bonds, there are 2 bonds, but one is sigma bond and other is pi bond, so don't confuse. So this carbon is sp2 hybridized, right? This was all about hybridization, how to find a hybridization. I hope you understand now how to decide hybridization at each atom.